And last one, up to now, we talk about the analog signal. And here we talk about digital, right? And digital actually, previously we have a sine wave, but right now not sine wave. So we have 1, 0. But this time we change level from 1 is 1, 0 is 0. And so that how to have the frequency shift key-in signal. Okay, 1 we have a high frequency, 0 we have a low frequency, 1 and 1 high and high and low. So this is a mapping. Something like this is a mapping. Right? And that's all. So we have the given signal 1 and 0. So we just pass on this one to have the so-called frequency shift key-in, and the frequency shift key-in try to carry different information, right? 1 and 0, 1 and 1. So this is a way to have the information carrying. About this, I think it's okay, right? But how about phase? Phase, look at this. Should we have the same phase? No. Actually, we have 180 because we change it. We have an upper one, but we have a downward one, so of course we have the phase change of pi. And so that, oh, okay, this is this phase 1 and this is phase 0. So we have this. But should we prefer this one? Normally, no, because we don't want to have the maybe a rough change. Even it's the fast change, but it seems to be somewhat strange, so we don't like this. So normally, we don't prefer these. But yeah, it's possible to have the phase shift key to have the phase 0 and phase 180. And so that we have the resultant phase shift key signal. Right? Actually, we have a quadrature phase shift key, and so that we have these. We have 4 different phases. Right? That's true. We have 4 different phases. Or maybe you don't like that one. You have the 4 phases here. And so that we have the in phase, some like horizontal and the vertical one. So we have I and Q. All right. We have in phase, and we can show these. Here we have previously we have I here, something like horizontal phase, and Q phase. That says, why we want to have I and Q? If we can map signal space to the current space based on the plane to show something. So actually, we can have, for example, cosine. For example, here. For example, oh, this one actually, it should be sine, and this one should be cosine. So actually, we will have a signal, sine and cosine, but we have the plane to show the signal. All right, something like that. And so that we have I phase and the Q phase. And it's time for BPSK binary flashing, and then we have the single one, maybe sine again, or maybe cosine, right? So we have a positive one and negative one. Previously, we have a positive one or negative one. And right now, why negative one to denote one? It doesn't matter. We just want to let you know, okay, we can have 2 choices. For QPSK, actually, we have these. Or maybe we can have a big degree rotation, so we will have these. So previously we have two choices. One, the current one, and the second set should be the 4 points with crossings. All right, so this is QPSK. And here we have for the specific term, if we map signal, actually originally signal can have a basis. We have a basis, and the basis serving as the axis, and so that we have the current way to show the signal. And this current way to show the signal, it is called constellation. Here, this is the meaning of a constellation. Groups of stars, right? But currently it's signal, so we call the signal constellation. So somewhere we can have some collection of a single points, multiple points, or a single star or multiple star maybe on a plane, and then that plane shows a so-called constellation. And currently we talk about signal, so we call it the signal constellation. All right, so that's it.